Good afternoon. This is Vijay Kumar. I am going to present what I did in internship. I done internship at RUHM Innovation Private Limited, and I worked on IoT based solar plant monitoring system. Here an overview of an project. Introduction: a solar photovoltaic plant, monitoring goals of a solar power plant, and the parameters of solar power plant, and applications of IoT and photovoltaic monitoring and control, and then conclusion and future scope, and lastly applications. Here the introduction. The proposed system is based on the Internet of Things, which is aimed at monitoring the solar plants, measuring certain parameters such as light intensity, temperature, and output voltage of solar panels connected in series. The system can be used to detect the faults panel, with the major faults being dust accumulated on the panels. The system used to internet to transmit a measured data to a device anywhere in the world. Due to the availability of solar energy across the country, unlike another renewable source, which is have graphic limitations, the solar photovoltaic among all renewable sources providing to be most beneficial. Here the small introduction to the solar power plant. The PV modules. The PV modules is nothing but the photovoltaic modules. The photovoltaic modules consists of number of interconnected cells and encapsulated into a single long-lasting stable unit. And the junction box has a simple but important role, harming all the electric bits on a solar panel, protecting them from the environment. And then MPPT is nothing but maximum power point transit, and it converts DC to DC, optimizing the match between the solar array and the battery bank. And the inverter which converts the variable DC voltage into an alternating current. And the perinometer is nothing but a device which is used to measure the solar radiation from a hemispherical field. Here the monitoring goals of the solar power plant is diagnose the performance issues in the photovoltaic array or inverter, or that is soiling or incorrect alignment in the photovoltaic array or in an inverter. Optimizing of solar farms operations and maintenance, mainly panel cleaning schedule. Evaluation sections of equipment and installation such as performance compared to the nameplate's rating. Evaluate long-term system reliability, that is long-term reliability and performance during the inverter failure rates. Evaluation solar power plant designs. It's basically actual solar farms performance compared to the expected. Here the parameters of solar power plant. Here the number of solar photovoltaic cells are connected in series to produce an DC output. The the generated DC output from an photovoltaic modules is connected to a junction box. The junction box will collect the voltages from photovoltaic modules and fed back to the power controlling unit, which processed and converted back into the AC and directly give to the load. And the DC is stored in the batteries, which consists of hybrid inverters and battery and temperature sensors and solar radiations. Here the background of Internet of Things. The Internet of Things is the network of physical objects or things embedded with the electronics, softwares or sensors and network connectivity, which enables objects. This collects exchange of data, that is smartwatch and wearable devices, along with the wearable devices and smartwatches. IoT is expected to greatly transform the energy sector by improving the consumer side generation and side relationship. And the applications of IoT for solar power monitoring is IoT utilizes the computing facilities and software system for information processing and the knowledge digging. Using an IoT, human machines and machine to machine information exchange flow can be achieved. Here the block diagram of how using an internet controlling the solar power plant. Here the output is collected from two parameter in electric parameter and environmental parameter. This collected data is fed to the sensor network, which converts collected parameters into the next processing for data unit, and this converted data is fed to network layer for the processing, and this is sent over or exchange over and control over application layer. This is an architecture of an IoT. This physical world can be connected to information world via an internet, and the physical thing and virtual things which you are connected to a physical world. This shows an solar voltage output and solar current output and solar power output. This collected data from the solar photovoltaic devices. Here the conclusion: the IoT based remote monitoring will be ensure comfortable plant monitoring and display of yield and power earnings and status message via email to PC or mobile. It is an ideal solution to increase efficiency of an plant monitoring and presence of photovoltaic generation consumes and self consumption and recommended consumption and automatic intelligent control of loads and visualization of live data. Here the future scope: the system can be further developed in order to measure the power generated by the solar panels, and the received data consists of power and temperature and light intensity. The analysis of these trends can be utilized to discover the major faults that can be occur in solar panel. On the large scale basis, the phototype can be implemented with the sprinkler system in order for efficient and effective cleaning action of solar panels. Okay, thank you.